Good day to my panel, Sir Idil and Sir Azmi. So I'm Lim Si Jie from 4BA. Today I'm gonna present about my final year project. My title is Modeling and Control Design of a Ball and Beam Educational Tool. Let me simply describe about my project. I'm doing a ball and beam balancing system. It's used to balance a ball on the tilting beam, which can be rotated along the ball moving back and forth on top of the beam of a servomotor. This system involves simulation, analysis, and control by the use of MATLAB, and there are generally two types of configuration of ball and beam system. The first type was the beam was supported at the center and oscillation against the central axis, and the second type was the beam was supported at both sides of the system. So my project is belong to the second type. One side was supported by lever arms that connected to the output gear of the motor, and another side was fixed point that act as a pivot. Let me do some introduction about the ball and beam balancing system. The ball and beam system educational tool was an influential laboratory tool that helped engineering students to be more understand on analyzation in balancing control system. It can be used to test, analyze, educate, and demonstrate the effect of different control strategies with simple, easy to understand, and user-friendly interface allow users to manipulate a machine, collect and output data, and save space. Okay, let's move on to the problem statement and objective of my project. As we know that control system is widely used in laboratory in our practical world. It can be used in many industrial applications such as power plant or precise location control in production line. The concern is that the actual unstable system is typically unsafe and cannot be put in the laboratory. So, in order to achieve stability, PID controllers play a main role. It is implemented to the system. So, for my objective of my project, there was three main purposes. First, to identify the mathematical model that represents ball and beam system. Second, to design a professional plus integral and derivative controller PID for ball and beam system. Lastly, to analyze the system performance of ball and beam balancing system by using MATLAB software. Next, let's take a look on my research methodology. My whole workflow for my project was roughly separated into 4 phases. The first phase is literature review. I have referred and investigated on the project that has been developed by previous researchers that related to various models of the ball and beam system. So by comparing the result of previous projects that have been done, we can conclude out for the better technique to be applied and produce a better performance system. The second phase is about system modeling. It was described about the step from building test strip to simulation. We will obtain mathematical modeling from physical derivation and system identification after building the test strip. By using MATLAB software, we can get the regarding simulation result that produce mathematical modeling. The detail of the system parameter and also system equation were done and shown in the report. The design criteria of the system is set to the setting time should be less than 3 seconds and the overshoot percentage should be not more than 5%. The third phase of the workflow is design and simulation. In this phase, the method on how to control the ball and beam balancing system was proposed. Type of controller design will be compared and the suitable controller design for the system will be chosen. The simulation of system will be done by using MATLAB. Okay, next, the last phase is analyzation and performance interpretation. The system performance is analyzed and compared. The result of simulation analysis will be interpreted step by step from open loop response to closed loop response. Okay, now we move to the part of result and analysis. This part demonstrates about the simulation result and experimental result by using manual turning method of PID controller in MATLAB software. The desired distance value between the ultrasonic sensor and the rolling ball is set to 14 cm. Of course, this value could be modified by changing it as the set point of the system. This part also demonstrates about the calibration of ultrasonic sensor and the beam angle of the project. The calibration of sensor aims to prove the accuracy of ultrasonic sensor to read the position of the ball. So you see that the marking on the beam using ruler has done to justify the reading of showing in a serial monitor. So here I will show a short video about the calibration. Now we go to the part of the calibration of beam angle. This session is needed due to the inaccuracy of servomotor to move according to the instruction given. There was a setting done by coding a program code to instruct the servomotor go to the particular position. It's found that my beam angle is to be 100 degrees when my system is go to horizontal. So for the simulation result, it is done from open loop response to closed loop response. Here is the result for open loop response. It shows that the graph is go to infinity. That means that the ball is rolled off at the pin of at the end of the pin. So to achieve stability, the addition of compensator or controller is needed. For the closed loop response, we can see that the system is remain marginally stable with the addition of proportional gain. I will add the integral inside the system. The system response shows unstable due to the position of the pole at the system at the beginning of the complex plane. So in order to stabilize the system, integral proportional controller cannot be implemented. Now we go to adjusting the value of Kp and Kd. The first graph, I start with the Kp equal to 10 and Kd equal to 5. It shows that the setting time is about 13 something and the overshoot is about 50%. So just now I have talked about my design criteria is the setting time is less than 3 seconds and the overshoot percentage is less than 5%, right? So we need to adjust the value of Kp and Kd until we meet the requirement. So after several experiments of adjusting the value, we get setting time is less than 3 seconds and overshoot is less than 5% when the Kp go to 10 and Kd to 56. So here I have a short video for demonstration for simulation result. Now we comes to the experimental result. Let me show you about the video of demonstration of how where to operate. So here we come to the result. So the first graph show about the Kp equal to 1.5 and Kd equal to 0. It is a very high steady state error and long adjustment period. After I add the integrate part to the system, the overshoot decreased and the setting time also decreased. So I found that there are a very big significant difference between my simulation result and also my experimental result. This might due to the imperfection of my mechanical nature and also the mistake of my system parameter. So as conclusion, this project aims to design and track the system of ball and beam. Instrument mathematical model was developed. PID controller has been acquired using a practical model manual tuning method to ensure the most effective response. The analysis of system performance has also been done. Although the troubleshooting of system was very time-consuming, but it gave us a very great experience in hardware implementation of digital control. So this might cause to the big difference due to the consideration of mechanical nature. This might cause the difference between my experimental and simulation result. The limitation of this project is the system is naturally unstable, so it always needs the requirement for us to do the adjustment. So the ability for us to adjust the control design are very important factor to consider. However, experimental limitations are naturally different than the simulation limitation due to the time constraint. So for the future work for this project, I hope that the board and bit system closed loop output is analyzed using fuzzy logic and whole system as a hardware prototype is also implemented. Overall, it was a rewarding project and definitely add intuition to the concept learned in the course and launch us into the more advanced area of control system design. Okay. So for the project potential of commercialization is this project is suitable as an educational tool for control system stability learning purpose. Here attached with some reference that I have referred throughout the project. So that's all for my presentation. Thank you for listening. Thank you.